Okay. So R4, factoring polynomials, it might be recording, it might not be recording. I've already got one of these recorded anyway, so it's not a big deal. Your favorite thing, factoring. And as I've said this many times before, you can ask my kids in calculus, factoring is important. It's not going to go away. Pre-cal, calculus, it's all there. Okay. Greatest common factor, factoring by grouping, factoring trinomials, binomials, and substitution. Is there anything up there that we have not covered yet? We've done it all. How many of you are comfortable with factoring right now? That's expected. First thing in factoring, we must always factor out greatest common factor, right? Very first thing. So here are 4 examples, 3 examples, and sorry about the fact that the font kind of messed up here. Always start by greatest common factor. So looking at number 1, number A, letter A, 9y to the 5th plus y squared. 2 terms. Do those terms have anything in common? Okay, they both have y's. Okay? So they do both have y, so I'll write a y down. Now you said y squared. Why did you say y squared? Okay. Once you establish that every term has the same letter in it, you write that letter down with the lowest exponent. Whatever the lowest exponent is, they all have at least a y squared in them, right? And that's how you picked up the y squared. Okay. But I mean, you were right on. I was wanting some explanation. If I take a y squared out, remember factoring means starts with a D. Divide. Factoring means divide. So because I'm pulling a y squared out, I'm going to divide both terms by y squared. So 9y to the 5th divided by y squared is 9y cubed plus, because it's positive there, and y squared divided by y squared is 1. And if I was to distribute the y squared, would I get back what I started with? Yes. Okay. Now always ask yourself, am I done? Can you factor 9y cubed plus 1? You can always factor a 1 out, right? And then we'd never finish one problem. Okay. It kind of, 1 is a perfect cube, y cubed is a perfect cube, but 9 is not a perfect cube, so we're not going to get into that whole sum of cubes thing. We'll get into that later. Questions on letter A? Letter B, how many terms? 3 terms. Give you a second to write those down. We have 6x squared t plus 8xt minus 12t. We have 3 terms. Looking at it a piece at a time, let's look at the numbers. Is there a number that goes into 6, 8, and 12? The biggest number that goes into 6, 8, and 12 is 2. Do these 3 terms have anything else in common? They all have a t. They all have a t. What is the smallest exponent on the t's? 1. So the greatest common factor of this trinomial is 2t. Okay? Factoring means divide. So I'll now divide each of the 3 terms by 2t. 6x squared t divided by 2t is 3x squared plus 8xt divided by 2t, 4x minus 12t divided by 2t, and we have factored out the greatest common factor. Does that factor further? Negative 6 times 3 is negative 18. Can you think of two numbers that you multiply together to get negative 18, but add together to get 4? No? Okay, we're done. Part C. We have 14 times m plus 1 cubed minus 28 times m plus 1 squared minus 7 times m plus 1. Looking at the coefficients of 14, negative 28, and negative 7. Can you factor anything out of those? 7 goes into all of those. Is there anything else that all three terms have in common? They all have an m plus 1. Okay? M plus 1 is something, but they all have it. This one has it, this one has it, and the last one has it. So they all have an m plus 1. And the smallest exponent on m plus 1 is 1. This looks a little different than problems we've done in the past, doesn't it? Okay, but it doesn't matter. It's still a piece of a term. It's a factor of each of those three terms. If I factor that out, factoring means divide. Looking at the first term, 14 m plus 1 cubed divided by 7 m plus 1 is 2 times m plus 1 squared. Next term, 28m plus 1 squared divided by 7m plus 1. 4m plus 1 minus 7 times m plus 1 divided by 7 times m plus 1. 1. Okay. Any thoughts on this one? And if you don't like all the parentheses, if you wanted to, you could change like this set of parentheses to brackets. That means the same thing, right? We're experts on GCFs anyway, right? When a polynomial has more than 3 terms, it can sometimes be factored by using grouping. Remember, we're just going to groups of these things. Okay? So the first problem, mp squared plus 7m plus 3p squared plus 21. Sometimes it's required to rearrange the polynomial. You might have to write it in a different order. Okay. Looks like this one will factor just fine in the order that it's in. The first pair is an mp squared plus 7m. What do they have in common? M. Factoring m out of that leaves me with p squared plus. Am I going too slow, too fast, just right? How's the speed, guys? Good. Okay. Will y'all tell me to slow down if I need to? Please do. It's kind of different not having started notes for you. You're writing down everything, so. Okay. The second pair. And I'll always include that sign with that second pair. Okay? Because the sign of that second pair is going to determine the sign of what you're factoring out. Does 3p squared plus 21 have anything in common? 3, what kind of a 3? Okay, because this is a positive sign, it's going to be plus 3. Factoring a 3 out of that, I'm left with p squared plus 7. Am I done? No, because I now have 2 terms, and those 2 terms have something in common. All right? What do these 2 terms have in common? If I factor out a p squared plus 7, bless you, what's left? M plus 3. Am I done? Yeah. I'm done. Questions or thoughts on that one? Okay. Part B. 2y squared plus az minus 2z minus ay squared. First 2 terms, anything in common? Second 2 terms, anything in common? A -1. Okay. So can I factor it the way it's set up right now? No. Any suggestions on rearranging this?
Y squared next the 2y squared.
2y squared minus ay squared, like that, plus az minus 2z. Did I change the value of my expression at all? Are all the signs the same? Signs go with the same terms, nothing's changed. Okay. Alrighty. So if I was to look at the first 2 terms, do they have anything in common? Okay. Factor out y squared, what's left? Okay. Looking at that second pair, do they have anything in common? What kind of a z? Plus z? What's left? Do those 2 terms have anything in common? No. Do they have anything that kind of looks like they might be in common? What? Okay. So is there any way that you can think of to, can I make 2 minus a minus 2? Or can I make a minus 2 minus a? Legally. Is there a way to do it? We can't set things to 0 because I'm dealing with expressions and not equations. Any thoughts? I'd rather you answer and be wrong than not answer at all. Huh? Okay. I like where you're going with that. Distribute a -1. This is an expression. Because it's an expression, I can't just introduce new things to it. Okay? If I had an equation, I could multiply both sides by -1 or something like that. Okay? But what you're telling me is the only difference in these two things is the signs are different, right? Okay. I can't multiply by -1, but can I factor a -1 out? Right? Okay. Let's leave the first term alone. And it doesn't matter really which one you do. We can actually have two different answers on here. They're going to actually be the same. It's just going to be a difference by a factor of -1. Okay. So if I took out of this guy right here, if I took a -1 out of that a minus 2, there's already a z there. So that z would become a -z. Right? -z. And if I factor out, remember factoring means divide. If I divide each of those terms by -1, what is a divided by -1? -a. What is -2 divided by -1? +2. So I end up with 2 minus a. Any questions on that? Okay. Guys, this is a very, very powerful tool, factoring out a -1. We do it with fractions, we do it with expressions, we do it all the time. Now do I have two pieces that are the same in the two terms? Yes. So now I can factor out that 2 minus a. And what's left? Y squared minus c. If you're the type of person that doesn't like an expression that starts with a constant, I could actually make this a become positive by factoring a negative out of that. So another way to write this answer would be pull a negative out. A minus 2 times y squared minus c. That would work too. Any thoughts? Any ahas? Not like take on me. Aha. Different aha. You don't even get that, do you? Huh? You're with me? Great song, right? Take on me by aha. That's it. Okay, part C. 4x cubed plus 2x squared minus 2x minus 1. First pair. Anything in common? 2x squared. Factoring out 2x squared leaves us with 2x plus 1. Perfect. Second pair. Minus 2x minus 1. Anything in common? -1. Why negative? Because it starts with a negative term. Always, whatever that first term is, that's what you're factoring out. And really, -2x minus 1 don't have anything in common. So if nothing, then always 1, right? All right. So factoring out -1 leaves us with? Okay. Next step, factor out 2x plus 1 leaves us with? And are we done? Is 2 a perfect square? 2 is not a perfect square, so no. If it had been a 4 or a 9, or not be done. Okay? But always be looking. Okay? Questions, comments, complaints, concerns, scares? I don't care either. Just kidding. All right. Here we just have trinomials. We're going to factor if possible. Starting with letter A, 4y squared minus 11y plus 6. First step, greatest common factor. Does 4y squared minus 11y plus 6 have anything in common? No common factor. Okay. What is my leading coefficient? That's 4y squared is the leading term. What's the leading coefficient? Y squared is a variable. What's the leading coefficient? 4. Coefficient's the number in front of an expression? Okay. Too many words. All right. So when you're factoring trinomials, if A is not 1, we did a lot of different methods last semester. We did box method. We did the snowflake. We did grouping. Remember all those? Okay. And if I remember correctly, the majority of you preferred the snowflake? Okay. What goes in the top center? A times C. And we're talking about the whole term, right? So what goes in the top center? 24. What goes in the bottom center? B, which is negative 11. What goes in the top left? 4y. Top right? 4y. And what goes in the last two wedges? And how did you get, why did you choose negative 8 and negative 3? Right. So I need two numbers that multiply together to get 24, but add together to get negative 11. And those numbers are negative 8 and negative 3. What do we do next? Okay, yeah, reduce if possible. Does 4y over negative 8 reduce? What does it reduce to? Y negative 2. Does 4y and negative 3 reduce? No. So what is my answer? Y minus 2. And does it have to be in that order? No, you could have written down the 4y minus 3 first, right? Okay. How are we doing? Okay. Do B. Multiplies to get what? And adds to get. A little bit of struggle on getting the two numbers. Doing it by hand, we just think about ways to get 30. Multiplying two numbers together to get 30. 1 times 30 is 30. Is there any way to add a 1 and a 30 together and get a negative 7? No. 2 goes into 30. 2 times 15. Can you get a negative 7 out of 2 and a 15? No. 3 times 10. 3 times 10 is 30. Okay, so we're looking good. We don't have to go further. We don't have to worry about 5 and 6. So how can I make 3 times 10 be a negative 30, and then a 3 with a 10 get a negative 7? Okay, bigger number's got to be negative. Is that going to work? Okay. And we write those in either place. It doesn't matter. 3 and negative 10. Does 6p over 3 reduce? Reduces to 2p over 1. And does 6p and negative 10 reduce? Reduces to 3p over negative 5. And that gives us our factored form. Our answer becomes 2p plus 1 times 3p minus 5. Good? Any input? Okay. Part C. Greatest common factor? No. Part C is 2x squared plus 13x minus 18. No greatest common factor. So we can snowflake it, see if it works. A times C, negative 36. B is 13. Top left and top right, 2x. Products to get negative 36, but add together to get 13. And we can do it again like I was up there a while ago. Getting 36, 1 times 36. No 13 out of that. 2 times 18. No 13 there. 3 and 12. 4 and 9. So is negative 4 and 9 going to get you a 13? Okay, so does negative 9 and negative 4 get you a negative 36? So what are we going to do? We tried every possible combination, didn't we? Okay. This would be considered prime. Like the number 7. right? What can you multiply together to get 7? Just 1 and 7, right? That makes it prime. What? I don't get it. Oh. You think they might have some 13s in it too? What? What? Huh? Oh, I don't care. I mean, I do care, but take care of you. All right, part D. Is there greatest? Oh, that's right. Cubed plus 24y squared minus 16y. Okay, I'm hearing 4y is the greatest common factor. What are y'all thinking? 8? Okay, so 8 works too, and 8's bigger than 4, so we're going with 8 so far. Anything bigger? No? Okay, factor out 8y. What's left? Okay. If you would have factored out the 4y, you'd have to look at it again, and you would have seen a lot of even numbers. So you'd have to factor out another 2, and that 2 would have combined with the 4 to give you the 8. Okay, so if you don't see the biggest prime number at first, always ask yourself at this point, was that really the greatest common factor? Okay, so looking at what we have now, does anything factor out of 2y squared plus 3y minus 2? No. So we did take out the greatest common factor to begin with. Now we need to see if 2y squared plus 3y minus 2 factors. Do not forget the 8y in your final answer, okay, because it's going to be there. We can do our little snowflake. What's a times c? -4. Good. Remember, we're factoring what we factored it down to. Don't go back to the original problem and take 16 times -16. You're going to cause all kinds of problems. Our new a is 2. Our new c is -2. B is top left, 2y, top right, 2y. Can you think of two numbers that multiply together to get -4? But when you add them together, you get 3. 4 and -1. Order doesn't matter. 2y minus 4. 2y and 4 reduce to y plus 2. The 2y minus 1 does not reduce. Is that my answer? Got to write down the 8y. Okay. Questions there? Okay. And because I have time, because we can actually finish this lesson next week, I'm going to go ahead and stop there before I get into the next little problem, and you can work on your assignments. If you weren't here yesterday, you might want to get connected to Canvas. Let's make sure everything's working.